I see that Brandon and Colby are playing Call of Duty. That's just a shame. Shame, shame. Alright, let's get back to work. This is going to be the last quiz for the day, for the week. We've done a lot today, and I just think this is good. This is a good stopping spot. Okay, I will put up some review stuff. I'll link you guys to my some of my circuits that I've got made up. All right, Tom Loftus. I will have to figure out what Tom's talking about. I'm sure he's watching the chat. Well, maybe. Nobody's watching, but he'll eventually be watching. Let's see. A circuit has a 120 volt, 60 hertz source. There are 3 inductors with values 8 millihenries, 800 millihenries, and 80 millihenries connected in parallel. What is the current in the circuit? Alright, so let's draw it. Alright, we got what do we got? 120 volt 60 hertz source? Yeah. Don't save? Okay. 120 volt 60 hertz. Then we have that's parallel, so it's like that. And one last one. All right, so this was 8 henries. Was it 800 millihenries? 800 millihenries and 80 millihenries. So, converting that all into henries, 800 millihenries is minus 3, so you go back 3 to get it into henries. So that's 0.8 henries, and then 80 millihenries, or 8 is 80. And it's still minus 3, so you start here, 1, 2, 3. Alright, so that's 0.08 henries. 2 ways we can do this. We can convert each of them using L1, L2, L3. X of L equals 2 pi FL. We can convert each of them using that. Or we can combine them using, or we can convert each of them and then combine them, or we can combine them and then convert them all at once. I'm going to convert them all at once after combining them using the reciprocal method. So just like we did earlier with the reciprocal method, it's going to be 8 to the negative 1 plus 0.8 to the negative 1 plus 0.08 to the negative 1. Close it, 1 more to the negative 1. Let's open it. 8 plus 0.8 plus 0.08. Close it 1 more time. 0.07. So L total is going to be 0.072 henries. Now we can take it into this formula. So we know what 2 and pi is. So 2 pi frequency. Oh, that's supposed to be 60. Frequency is 60. So 2 times pi times 60 times 0.072 henries. That's going to be our total X of L. That's what we got. X of L total. So calculator. 2 times. Do I have a pi button? There's the pi button. Times 60 times 0.072 equals 27.14. So X of L total is equal to 27.14 ohms. X of L is inductive reactance and is measured in ohms. 27.14 ohms. So, let's do that up here. X of L total is 27.14. Then we have I total and E total. I got 120 volts. And if you've been paying attention all day, you should know the next step is 120 divided by 27.14. 4.42 is going to be the answer here. Amps. So other than this part right here, let's turn it red. Other than that spot right there, nothing we did in this circuit was different from working a regular parallel circuit. .3 amps. 880 connected in parallel. So where did we go wrong? Because we are significantly off from that math. We did I don't see where any of what I did was wrong. Why do I keep clicking that? 27.14. Man, less using 3. 1 divided by 8 plus 1 divided by 0.08 plus 1 divided by 0.08. No, all that's correct. Surely it's not like a rounding error off. 2 times 3.14 times 60 times 0.072. 27.12. 120 divided by 27.12. 0.12. Okay, yeah, that's the same number. Huh. It's weird that I'm wrong. Somewhere. One of these is wrong. I wouldn't add an explanation to this one, would I? Unless it's that they converted each of these one at a time. Where's that feel? I think I ripped this one from the homework. That feels right. I'm not going to waste a lot more time. It's already been 10 minutes and we're on question 1. We only have 16 more questions, so that's 160 minutes. Hope y'all are in for the ride. What is the current through L2? Well, this one's simple. Just like the last one. This one is really simple. So you have the circuit right here. Well, the same current, the same voltage is dropped on each leg. So L2 gets the full 120 volts. So you could ignore the rest of the circuit, essentially. So 6 henries. So we have to calculate X of L. X of L equals 2 pi 60 times 6. So 2 times 1/4 times 60 times 6. 2260.8. 2260.8. So our voltage was 120 volts. So 120 divided by 2260.8 as a volts divided by ohms is equal to 0.053 amps. That would be 53 milliamps. How'd we do? Nobody got this one. Wow. Crazy. It's current through L1. Giving you another shot at it. L1 was what? 3 henries. Is the next one L2 or L3? No. Okay. So this one's 3 henries. So doing it again, just lower on the board. X of L equals 2 pi 60 times 3. That's going to be 1130.4 because it's half. E total is still 120, so you take 120 divided by 1130.4 ohms, and you'll get double, actually. You'll get double the amperage because you have half the resistance, right? 120 divided by 1130.4, 106.106. Converting that to milli, so 0.106. Convert that to milli. You go 1, 2, 3. Put your decimal. It's 106. There we go. If the frequency of a purely capacitive circuit is increased, the current in the circuit So frequency of purely capacitive circuit is increased. So let's look at our formulas. So X of L is equal to 2 pi FL. X of C is the opposite. You get 1 over 2 pi FC. So, if you increase something down here, if any of the stuff down here goes up, let's change that to a different color. Black. If any of this goes up, this is going to go down. And X of C is equal to ohms. X of L is equal to ohms. So in the X of L formula, if any of this goes up, well, it's a multiplication problem, isn't it? So if any of this goes up, X of L will go up. And X of L is ohms. So it's the opposition of the flow of current. X of C is also the opposition of the flow of current. So let's look back at our question. Frequency increases. Current does what? So if frequency goes up, well, X of C is going to go down. If X of C goes down, the opposition of flow of current goes down. If there's less opposition, things happen faster. It increases. Was the total inductive reactance of a 50 hertz circuit with 400, 700, and 600 millihenry inductors in series. So again, I'm going to do like I did last time. I'm going to combine them all together. So I'm going to convert these. So that's going to be 0.4, 0.7, and 0.6. Going to use the reciprocal method. Open parentheses. 0.4 to the negative 1 plus 0.7 to the negative 1 plus 0.6 to the negative 1. Close the parentheses. Do one more. So that's 0.178. So L total is 0.178. We'll say 179. We got 2 pi 50 this time times 0.179. 2 pi 50 times 0.179 gives us 8.95. Hang on, that didn't times 2 times pi. It didn't give me all the numbers. That was weird. 56.23. Survey says that's not even an option. What? Am I in radians? No, because it's doing 3.14. What the? I'm going to have to come back to these. 50 hertz. 400. How'd we do? I'm like not just a little bit off. Series. You know what? This is what I missed. series. So instead of it's 0.4 plus 0.7 plus 0.6, 1.7 is the answer. Or not the answer, but times 2 times pi times 50. 534.07. That last one wasn't in series, was it? That would be embarrassing. No, it was parallel. Okay. I still don't know why I missed that one. But that answer's close enough. That's what I would put with what I found. This is the same, but slightly higher hertz. So it's going to be a slightly higher answer. It's going to be 640. So go back to that previous conversation. If the frequency in this 2 pi FL, if the frequency goes down, so if the frequency goes down, X of L goes down. Frequency goes down, X of C goes up. There is a point, those two things cancel each other out. X of L and X of C cancel each other out, and there is a point in a circuit that contains both of them where the frequency is perfect and they balance and they completely cancel each other out. My vacuum's stuck between two legs of a table and it's spinning. It's turning like 360 degrees and trying again to go in the same direction. When the frequency of purely inductive circuits decrease, the current in the circuit increases. Yeah. Connecting additional inductors in an AC series circuit will cause the circuit current to. So, adding inductors in series will increase the inductance. Increasing the inductance will decrease current. So this is micro. So let's get over here. It's a 50 microfarad. $50 microfarad. Micro is minus 6. So you go 1, 2, 3, 4, 5, 6. And that's it. So, that being said, okay, we're going to do the 1 over 2 pi FC. Easiest way to do that in the calculator is going to be open the parentheses, 2 pi FC, close parentheses, to the negative first power. Let's see that in action. Let me get all the numbers one more time in my head. Okay. Open parentheses, 2 pi. Oh, okay. 2 times pi times 60 times 0.00005. Close your parenthesis to a x negative 1. So x of C is 53 ohms. 120 volts divided by 53 ohms. That's a O, not omega, is equal to 2.26. Show me 2.26. Okay, same question, lower frequency. Lower frequency means higher resistance. If the X of C is higher, amperage is going to be lower. There's only one answer that was lower. A 48 volt source is driving 24 milliamps through an inductor at 100 kilohertz. What is the inductance of the inductor? Is 3.19 millihenries. I'm going to skip this one. This one's complicated and not totally important to later. It is a good one to know. I will skip this one and I will gladly answer it for somebody if they ask. What's the value of 50 microfarad capacitor? We just did that a couple questions ago. Total capacitance of several capacitors. Yeah. So capacitors in parallel is like resistors in series. I've said that a bunch of times. Capacitors in parallel like resistors in series. Inductive reactance of a coil with an inductance of 500 millihenries when connected to a 10 kilohertz supply. Okay. This one's pretty simple. 500 millihenries, so this is going to be 2 times pi times 10 kilohertz, so that's 10,000 hertz times 0.5. 31,415, so that's 31.4 kilo ohms. This is just using the inductive reactance formula. Okay. This is the time constant formula. We are not covering that anymore. It's not going to carry over into anything we're doing. And another time constant formula. So don't worry about the time constant stuff. Alright. So that finishes that. This is going to be it for the day. I will post in the Discord about that there's no more quizzes for the day. And I will post some of the packets of circuits that I gave you guys before you left class last time. That probably y'all threw away. Or you're going to tell me it got lost in the flood. That seems to be the common excuse for things I send home. Alright. I will see you guys in 2 weeks. Bye.